the PID value is less than 0, negative value is a fork failed. Then in case PID is 0, which means this is the child process, we run the ls command. Then in case of the parent process is waiting for the termination of the child process, then child completed. So after compile, so you can compile the GCC -O option is the executor file a.out, then the source file, this is the source file aa.c. After you compile it's a warning, so don't worry. So then run the aa.out. If we run the aa.out, this is the program. So this is the output of the child process. Okay. So after exec, the LP, the exec run the ls command, output is here. Then the parent process, once the there are two processes running. This is a child process and this is the parent process. So we can see clearly the current process create the child process. So then, which means our operating system uses a tree structure to manage a number of the processes. So can I see such the process tree? There is a command like the ps3. This is not installed here. So let me install the there's no PS3 Debian OS. Let me show you this one. I tested. So the bash shell on the MacBook, there is a PS3 command. So it shows the process tree like this. So let's see the top of the, yes. So this is launch it is the init process. So in this case, the Mac OS use the name of the launch it. So launch it actually here, launchpad. So launch it is launch D. Daemon is the init process, the first process. Then that create the number of the children processes. Most of them are system processes, like the syslog is a log, the daemon, and user event daemon, and so on. Then mine is, so my current shell is, where is it? Yeah, here. So this is I learned the PS3 just before. The PS3, so this is the shell. So my current shell is the 62853 that create the child process, the PS3. Then the PS3 actually run this kind of command to get the information. So then we can easily see how the process are created and managed. Sometimes if you find any defunct or the open process, we can define the process ID and send the key signal to terminate, forcefully terminated. So this is the process management. So let me change it back to here. Let me quickly check Debian, Christopher found the name of package is a PSMI, miscellaneous. So MISC. So Debian OS use you can use the apt get to install that. Thanks so much, Christopher. Okay, then continue. So in case of Windows API, the Windows API has the name of the create process, the system library Win32 API that actually combine both fork and exec. When you take a look at their argument, actually argument is a combination of the fork and exec. So you can easily create the child process using this example. Then we have seen the termination of the process. So termination of the process here, once the instruction of the child process is done, then inform to the parent process which created the child process. Then this parent process should have the wait. This wait signal, the system library is waiting for the termination of the child process, then going on. So this is the process termination. Then, as we have seen before, the process has the number of states. Basically, it has the new, ready, and run, and wait, and the terminate. So this is the termination state. Okay? So what if I want firstly to terminate the process? How can you firstly terminate the process? We can use the system library, which is called the kill. So kill is the command, okay, to send the signal. There are different levels of the kill signal. So 0 to 15. -9 is the most powerful. So if you send the kill signal with the -9 option, so for example, so my share is 62853. Okay, the process ID is this one. So then you can send the kill signal with the -9, then the 62853. So kill myself. What happens? So it's terminated, which means it's forcefully terminate. So even though there are remainder of the instruction, send the kill signal, then it's return back, terminated, then return back to the parents. So the process is terminated. Okay, so that is the first termination with the kill signal. If you want to know about the more, for example, the man, the kill, so you can see the more information about the kill, like using the man page, or you can search the Google. I think this one. Yes. Okay, so also we have seen what is a zombie process, what is an open process, and what is a demon process. Okay, so so we have a number of processes in the operating system. However, they are not working independently. They work. They need to communicate. They work together. It's a cooperative process model. So which means we need a communication model. So there are 3 types of communication model, as I introduced the last time. One is So one is the shared memory. So shared memory is basically there is an operating. This is a memory, lower address, higher address, and there are a number of processes: P1, P2, P3, like this. And we are going to create the shared memory area. So this shared memory area is like the bulletin board in the dormitory and department. So process P3 put the message, then the other process can take the message like that. This is a shared memory approach. Another one is a message. So we can create the queue area. So this is called the pipe. So we can create the pipe. So this pipe, the shared memory is you need to know the address of such a shared memory. Then anyone can get the data. But the message queue is based on the queue structure. It's the first in, first out. There is a message like that. This one is called the pipe. So you can put the message over here, and another process can take the message from the pipe. So this is another approach method for the communication. The third one is So it's okay. The programming is based on the network programming. So client server model. So using network programming. So if you already took the network class, you probably did the programming assignment to create the socket program. So client and the server. So you need to know the two things. First, the protocol. So a lot nowadays in internet protocol you use the TCP or UDP. So you can select one of them. Then to use the TCP or UDP, you should have what? IP address, because this the protocol is based on the IP. So then the plus what? Port number. So using IP and port number, you can create the link for the communication. Then you can send the message and receive the message. So this is a socket programming. So these two works in a inter-process communication. So it's called IPC, inter-process communication. So it's called IPC. But this one, as long as connected to the network, so even the different server, you are able to communicate. Nowadays, more and more, socket is being used, especially the higher level, the programming, like the Java. Java uses RPC, remote process communication. So this is based on the socket. Okay. So then, this one is the operating system method. But in terms of hardware, so this one is use a network, and also this one use the memory, and also you can use the something bus for the communication. So these are the hardware, the method for the communication. But this one and this one is most popular for the inter-process communication, the process communication. Okay. We will see the little bit more details. So this one is the left-hand side, the shared memory. So shared memory is the allocate. So we can create the shared memory area. How can we create such a shared memory for the communication? How can we create?
Possibly, like the operating system can reserve a certain section of memory and then have that address be available to.
Can you create, as the process, can you create the shared memory?
Or I don't think you can, but it just has to be.
You can create using system library. Operating system provide a way to create, reserve the memory area, so you can use that, the shared memory. So it's usually named SHM something. So you can create the memory using system library. Then
it's not constant, like we can change size at any time.
Oh yeah, sure. You can specify the size of the memory. You can actually use the memory in your program using MALLOC, the system library, memory allocation. So think about the memory. Sometimes many of the students here to create something, the data structure on the memory or such a thing. But you are able to create a file, right? In your program or even the application, you always create a file. Same thing on the memory. You are able to create the memory structure. You can reserve the memory structure using MLOC, CLOC, RLOC, also shared memory, even pipe. Using such a system library, you are able to create. What about this one, the message passing, the queue pipe? You can create the message. Okay? If you are familiar with the system library, that is the system programming, Unix programming, and even Windows, the system programming. So based on what? System library. So you are able to create. We will see the example of that. All of them are based on this programming model, very well-known programming model, producer, consumer problem. Sometimes, think about what is a modeling. When you encounter certain problem, you need to figure it out. What kind of problem is this, right? In other words, you are going to model such a problem. Then, such a communication, just using shared memory, using message, using socket, whatever, we can model, standardize as a producer and consumer problem. What is the most popular producer-consumer problem model? Is used. Application. Client-server. So client-server model. So you are using every time. So like if you click the web browser, then access any web server. Web server is the producer. And web browser, me, is a client, is a consumer. So I request and the web server return. So we can see such a communication problem as the producer and consumer problem. Then we should have something in between, producer and consumer. So media. So what kind of media we use, depending on that, we have message passing and message queue, or the shared memory, or network channel, communication channel. So the only difference is what kind of media we are using between producer and consumer. So in terms of such the producer and consumer problem, so it's very easy to understand such a communication method. Okay, then first the shared memory. So IPC means inter-process communication. So among the IPC, the shared memory is one of the methods. So we are going to create such the buffer area. Buffer means the memory, the shared memory area. So, for example, in terms of producer and consumer, the producer increase the buffer, put the data. Consumer read the data, which means it's reduce the buffer. So depending on the types of buffer, so you can create the unlimited buffer or the limited buffer and the zero size buffer like that. Okay, so this is the process, the producer, the model, the using shared memory, based on the buffer size, buffer. This is a consumer process model. This is a model, it's not the exact code, but using the model, so you are able to do the coding, the programming. Okay. However, when we are using the shared memory, there will be the issue of the race condition. So race condition means, because we have the shared memory, it's a shared area. So what if we put the data like the 1. So this is a producer. And there is 2 consumer, C1 and C2. C1 usually plus 1. C2 is minus 1. Okay? So read the data 1. And plus 1 is going to be 2. Minus 1 is going to be 0. Then update the 2. But update 0. We cannot guarantee the output. This is called the race condition. Shared memory caused such a race condition. This race condition is named as the synchronization problem. So, in case of the multitasking, multi-programming, always we need to think about the synchronization issue. So synchronization happens every time, everywhere. Because we are not having the only one producer, one consumer. Instead, the multiple, the consumer, multiple, the process are running to access the shared data. So we will discuss more details in the chapter 5 and 6, how to address such a synchronization problem. Then another type of the IPC, the process communication, is based on the queue message passing. Sometimes it's called the message queue and or the pipe. So we can create such a on the memory. It also the message also use the memory as a hardware. Then we can create the message such a pipe. Okay. There are different types of communication. Okay. So, but I think that you guys can easily understand the different types of the communication, direct and indirect communication. The communication means we had for the buffer, in case of a message, we are going to directly use. So like it's like the message box. It's the first in, first out, and message 1, message 2, message 3. Then the consumer read from the beginning like this. Indirect communication means, so we are going to use something, the address, okay? So address. So like the, for example, in your dormitory, each student has a room number. So we are going to use a room number. So this one is, this message is for 101, this message is for 202, this one message is for 403. Then the consumer take the message only using the ID. So this is called the indirect communication. For example, email uses such an indirect communication. Then, in terms of the synchronization, so there are different types of that. The blocking, non-blocking means, simply you can understand the blocking and non-blocking is the, you confirm, acknowledge. You send the message, then the check whether the receiver, consumer received the message or not. If yes, then the send another message. On the other hand, the non-blocking means that doesn't care whether receiver, consumer received the message or not, just the same. For example, what about the email? Email is a blocking or non-blocking? Email is the blocking or non-blocking? Do you know whether the recipient received the email or not?
That means I can't block an email or no?
So whether you are able to check?
No.
No, there's no way actually. So unless it's the same company, email. So but that's the different method. So email is the non-blocking the communication. You don't care.
Yes.
Right? So that is the blocking and non-blocking. Okay. So let's see the example of the the IPC communication. So first the POSIX, the Unix, the one. So it uses HM_FD system library. It may be different name. So different variation of the operating system they use, but basically they either SHM open. So sorry, SHM open is used, but the depending on the operating system type, the kernel type, they may use a slightly different name, but this is the one. It's very similar as later we will see when we in operating system, when we are using the resource, always open, use, close. 3 steps. So when you are using the file, you need to open file, right? Then use the file, right? Or update, whatever. Then close the file. Network connection, you open the network connection and use the connection channel, then close it. Always open, use, close these 3 steps in operating system. Same thing when you are using memory. You need to open the shared memory, SHM open, and use it after you use it and close it. SHM, shared memory, close. So always 3 types. When you open it, you can specify the name of the shared memory, and also you can give the permission. Whether this is a read only, read and in this case a read and write. Okay? And the 668 is we will see. Access control later. What's the meaning of such a number? Sometimes they provide system library additional the system library like the truncate. truncate is the delete all the contents, but the shared memory will be existed. And the truncate size is the 4K. So remain the 4K, the old truncate, the other, like that. So this is the example of the C program based on the POSIX, the shared memory. You can see the. We'd like to send the hello world style, such a message. You can see the shared SHM open, and then the name is OS. So shared memory name is OS. First we initialize the truncate. Size is the 4K. So we are going to create the 4K size. The shared memory name is OS. Then we can create the memory map. Okay. Then the use. So sprintf. Very similar as what? Printf in C. Printf is a display the message. So you can pointer. So we can create the pointer address of the shared memory as a memory map, the system library. Then this message will be copied to here. The first one is hello. Then consumer process can read using the same approach with this data. So this is how it works using POSIX system library for IPC. This is a consumer. So you can see the consumer. You can open that, the created shared memory as a open. It's a read-only this time because it's a consumer, right? Then you can create the pointer of that the memory map. Then you can read. After you read, this is what? Just pointer, right? Then display the message. After everything is done, remove the shared memory object only. In case of the Maho, so it's a microkernel on the macOS. They are using the Maho port allocate and Maho message, the system library. I'm going to click to this part. And what about the Windows? Windows also used such the inter-process communication. It's named as the local procedural call. It's the IPC. Okay, so they are using such the mechanism for the producer and consumer, the model. So client is the consumer and the server is the producer. So first you create the connection, then the shake hand, then share the data. At that time, the shared object will be created minimum 256 bytes. So this software, that is based on the shared memory. Next approach is using pipe. Okay, the pipe is mostly the two-process communication. You can specify the pipe. So you already use the pipe, like when you are using the share. So PS minus EF is too low. Pipe more. So more is the command page by page display. So this is the pipe. So in the shared memory, instead of writing the output of this one hard disk drive and here the read it, so this one takes the time. Instead, we are going to create a pipe. This, so output will be here as the input of the pipe. Then this one will read. So we don't have to create the real I/O. Instead, we can directly use the memory. Okay, so this is a pipe. There are different types of pipe. Named pipe is, this one is not named pipe. It's an anonymous pipe. Even though pipe is created on the memory, so we don't know what is that. So it's after the command, it will be gone. But named pipe, you can specify the name, then the other process can use such one. So like this is basically the queue structure, but you can create the bidirectional pipe. So each process can be producer and consumer. And this one child also producer and consumer bidirectional. Okay. Name the pipe, so you can create a pipe. Then you can specify the user of that. The third one approach is based on the socket, the client in the client server system, because you already learned the socket method in your network class. So I'm going to briefly. Let me check the chatting box. The question from the Christopher. At that time, you can control the permission. As long as you know the address, you are able to access the data from the memory. That is one of the issues of the memory. Okay, memory is, think about if you go to the West 200 years ago, so there's no boundary, no fence. But this is your land, this is mine, and how do you know? You need to measure and something like that. Memory is the same thing. As long as you know the address, you are able to access. So because of that, we need to, when you create the shared memory, you need to specify the access control. Like it's a read-only or read and write. Also, you can give the permission to the specific user or group or the public, like the 666 is kind of the access control. So we will see a little bit more details such as access control later. Definitely, we need to control the such access permission. So in case of the socket, so it's basically based on the network protocol, TCP or UDP we can use. And the IP address is the IP address and the port number is being used. Okay. So regarding to the port, there are sometimes a well-known port, and so you can specify the specific port number. Like the 80 is the HTTPD, and then the 23 is for the SSH and the so on. So TCP and the UDP, the connection oriented is TCP, and the UDP is the connector, the protocol. Different is the long time ago when we watch the live stream. Sometimes if there is a delay of the streaming, we can select the UDP. UDP does not care whether connection is made or not, just to send the data. So in case your network is not reliable, UDP is better. So this is a connectionless protocol UDP. Okay. So the difference is the connection first established for the TCP, then the send and request the data and receive the data. On the other hand, the UDP, the connection is just to send the request and the data, whether or not the connection is made. This is a socket program. So if you probably practiced such a socket program in your network class, so in Java. So it's a very simple. Actually, Java used the remote procedure called the RPC based on such a socket program for the communication. This is called the remote procedure call. So then I'm not going to explain details of this one in the operating system class. Okay. Okay, so that is the end of chapter 3. So in this chapter we have learned what is a process and how to manage the process and how to create and how to what are the status of the state of the process, type of processes, then how can they communicate each other using IPC method. So for your practice, so please actually I tried to do the exercise lab in the classroom and live, but it takes much longer time, it's not convenient. So GA, the BMC, create the YouTube video for the exercise lab practice. Please, after this class, please practice, go over the exercise lab with the help of the BMC's YouTube video. Okay, YouTube video is available on our playlist. Please go to our playlist on YouTube, then you can watch the video. Then you need to submit your proof of your exercise lab by capturing your screenshot. Okay, please submit your screenshot to the Canvas to prove you complete the exercise lab. Okay. So we are going to end today earlier. So any questions?
Professor,
Yes.
where do we upload the exercise lab?
Also already uploaded. So let me give the link for that exercise lab. Okay. Well done. Also, if you have the problem of connecting the virtual machine, please contact the GA BAMC. Also refer the email from the BAMC, so he will address the issues. I will give the link of that. Not this one. Okay, so I'm going to give the link to your chatting box.
Professor, is the link available on Canvas?
I think so. Yes. And I'm going to send out the email to everyone, the link of this playlist. Okay? Any other questions? Okay, thanks so much. Please start your project. The POSX and EXEC, I believe that it takes 5 to 10 minutes. Okay, but if you do not understand the concept, you don't know what you are doing. So it doesn't require programming skill. Okay, it's the understanding the concept of creating process. That is the main objective of the operating system project. Okay. So first, try to understand what is the fork and the EXEC and what the system library are available for the Debian OS, or if you are using the different operating system, find it. Like I'm going to use the Windows, then the Win32 and Win32 API, which creating process is. So please try to understand the concept of the process. Then the programming itself is not very difficult. Okay. So thanks so much for your attending today, and please stay safe. We have the confirmed case, and due is usually, I cannot remember, but maybe 1 week. So I'm going to check the due date for the exercise lab. Okay, I'm going to check. We'll let you know, and we'll send the email to everyone this evening regarding to the link of the YouTube list and also the due date for our exercise lab. Okay, thank you, and we will see you next week, Monday. Thank you.